and perpendicular lines, right? Whenever we're working with these or deciding if lines are parallel or perpendicular, it all comes down to slope. Okay, so real quick, if I need to find slope, it's rise over run. If I'm looking at a line on a graph, or if I'm given points, we can do y2 minus y1 over x2 minus x1. Okay, quick review. Now, parallel and perpendicular, what it means to be parallel is that these lines never touch, right? They're going to be side by side, right, and never touch. So these lines are the same distance everywhere you go, same distance apart, right? And then I know if lines are parallel when I look at the graphs or equations if they have the same slope. Okay, same slope. Perpendicular lines means that they do touch, so they're going to intersect one time. And where they intersect is going to form a right angle, right? And a right angle is 90 degrees, right? We label right angles with a box. So we put a little box in there. And that's what perpendicular means. Perpendicular means that those two lines form a right angle. They form 90 degrees. We can tell if lines are perpendicular when we look at their slope, if their slopes are opposite reciprocal. Opposite reciprocal. Okay, so the opposite is talking about the sign. So if you have one positive, one negative, they're opposites. And then the reciprocal is when you flip your fraction. Okay, so xy would be y over x. Okay, whatever your numbers are. So 1 or 2/3 would be 3 over 2 or something like that. So all we need to do right now is look at slopes, right? Look to see if they have the same slope, if they have opposite reciprocals for slope, or if it's neither one, then they're going to be neither perpendicular nor parallel. So for our 3 examples, I'm determining if their lines are parallel, perpendicular, or neither. We're going to do that by looking at slopes. So for the first one, both of these equations are in standard form. So we're going to put them in slope-intercept form so we can figure out what the slopes are. So I'm going to start with this first equation. 4x minus 3y equals 2. And I'm going to scooch up some so I have room. Okay, so I'm going to start by getting the y by itself. So I'm going to move the 4x over. So I have negative 3y equals, and I'm going to go ahead and put my 4x first. So I'm going to have a negative 4x and then a positive 2, so plus 2. Okay, then to get y by itself, I'm going to divide everything by a negative 3. So this one becomes y equals my negative 4, negative 3. The negatives cancel. So I have 4/3 x. And then I'm going to have 2 over negative 3, which is going to end up being a negative 2/3. Honestly, I don't even care about that part. I care about the part in front of the x. I care about my slope here. All right, and then I got to do it one more time with this equation. So we've got, let me make sure I got room to write. We've got 3x plus 4y equals negative 1. All right, so then I'm going to get y by itself. So I'm going to start by subtracting the 3x. All right, so then I got 4y equals, and I'm going to put that negative 3x first, then my minus 1. Divide everything by 4. All right, so I got y equals negative 3/4 x minus 1/4. Okay, and again, I'm not too terribly concerned with this guy. All I'm looking at is slope. All right, so then I'm looking here. I have one slope is a positive 4/3, and the other slope is a negative 3/4. So right off the bat, I got one of each. So they're definitely not parallel, right? And so I got a positive and a negative. It is opposites, and my fractions are flipped. So that means that these lines are perpendicular. You just got to look at slope, right? Some of them are going to be a little easier. Some of them, they're not going to have to solve for y first, but in this case, we did. All right, I'm going to do the same thing for number 2. I'm going to start with 4x minus 3y equals 2. All right, I want to get the y by itself. So I'm going to start by subtracting the 4x. So I'm going to have the negative 3y, and this is actually the same one we did over here. But we'll practice, and I'll put the negative 4x first. Right, then I'm going to divide everything by the negative 3. And we've got y equals, the negatives cancel, so positive 4/3 x and then minus 2/3. Okay, so I'm looking for the 4/3. I'm going to bring this guy down. Now you gotta pay attention. My x and y switched here, so you're still solving for y. So I'm going to add the 3x over. So we've got 4y equals, I'm going to put my x first with a positive 20. And then I'm going to divide everything by 4. So I'm going to get y equals 3/4 x plus 5. So I've got a positive 4/3 and a positive 3/4. So they are reciprocals, like the first one, but they're both positive, so they can't be perpendicular, and they're not the same. So that means this one is neither. Make sure we can see that. Okay, one more. Oops. All right, the first one already in pretty slope-intercept form, okay? So this is going to be my slope. Now, it looks kind of weird because I don't have a number. Remember, if there's not a number in front of your variable, you can assume it's a 1. So there's my slope. I got a -1 for a slope. And now I'm going to solve this one for y. So I'm going to get that one by itself. So I'm going to start by getting rid of the 3x out front by subtracting. So we got 3y equals, I'm going to put my -3x first, then my -3. And then I got to divide everything by 3. So we've got y equals -3 divided by 3 is a -1, right? Which I could write, or I don't have to put the 1 in there. -3 divided by 3 is a -1. Okay, so I do have two slopes of -1, but before we call it parallel, if I have the same slope, I do have to check for one thing. I have to see if it's the same line. Okay, because if I have two lines that are the same, that means instead of them being parallel, they're actually, oh, I really can't see that. They're actually right on top of each other. So that's not parallel because it's the same line, but you only have to check this if your slopes are the same. So my first equation has a +5, my second one has a -1, so this one's not the same line. So we can go ahead and call these parallel. So you're going to find your slopes, check to see if they're the same, or if they're opposite reciprocals, or if they're neither. And then you know if it's going to be parallel, perpendicular, or neither.